Alright, so this is the FPGA board after I've programmed it with the Lab 3 settings, and I'm just going to demonstrate how it produces the right outputs based on the inputs that I give it. So right now, all three of these switches are off, and the only LED that is on is the one representing 04. Obviously, because this is going to be, since there is a C naught and a B naught, that transfers to an output of 1 on the 04, since we've got NAND gates on that one. So we've got basically everything is off. When everything is off, that would represent that. Now I'm going to go ahead and flip C on. In this case, since we have a the C input is on, then the 03 is going to be on, because basically it will be functional if A and B naught or C is true. So that is true. I'm going to go ahead and put B on. In this case, the only one that is going to be on is 01, the output 1, because that one's on when it is A and C, or A naught and B. In this case, it is on because A is not on and B is on. And now I'll go ahead and turn B and C on. In this case, output 1 and output 3 are on. And we can sort of see why. In this case, it is just like before, A naught and B for the output 1. And then for 3, we have that it is C. Since C is on, the output 3 would be on. Now I'll go ahead and turn on output A, and right here we see that output 3 and output 4 are on. Since A and B naught are true, that would make output 3 light up, and with the NAND gates, if we have A, since A and B are not true, and since C naught and B naught are not true, that would make it so that the output 4 goes on. Now I'll go ahead and turn on A and C to demonstrate that. In this case, the output 1 LED is on since A and C are true, and output 3 is on since C is true. All right, and now I'm going to go ahead and turn A and B on, one of the last ones. It looks like only output 4 is true, because in this case, A and B are true, but C naught and B naught are not true, so that would make it's sort of inverted, and it makes it so that there is, if we look over here at the logic function, makes it so that we don't get two trues on the third AND gate there, and it would make the F equal to 1 or true. So that's why the light is on. And lastly, I'll go ahead and turn all the lights on, and in this case, this is the only way that we can turn on all 4 LEDs. 01 is true because A and C are true. 02 is true. The only way that the 02 or the output 2 LED can be on is if all 3 are true. Since simplifying that equation, it would in reality just be A and B and C, because C naught and C cannot be true. So the only way for output 2 to be true is if all 3 are on, and they are. Now output 3 over here, basically if C is true, then it's going to end up being true. And for output 4, since all 3 of them are true, that would make it so that the second AND gate on the bottom there, this one will not return true, and that would make it so this one doesn't return true either. And since it's a NAND gate, we have the function equal to true. All right, so that is our FPGA Lab 3. If you have any questions, let me know.